I had a question about number 10 on the cumulative practice test at the end of chapter 10. So I want to go through it with you. I did it myself, and this is how I came across my own answer here. So we go into this knowing that the mu of x, mean of x equals 3.5. I know the standard deviation of x is 1.71, and that represents one dice roll. We're talking if the dice is rolled 100 times. We're trying to find the approximate probability that the total score is at least 375. First thing we want to do is find the mean of 100 times. So we have the mean of once. If we do the mean of x times 100, 100 times, it's pretty straightforward. Just do 3.5 times 100. And that tells you your expected score would be about 350. So if you did this 100 times, you'd expect to get about 350. Standard deviation now, this is where it gets a little tricky. You can go a couple of ways here. This is the way I ultimately did it. Since we're dealing with standard deviation, we're doing this out of 100 times, I'm going to find the variance by squaring this, and then I can add it 100 times, or I could just multiply it by 100. Because again, I'm representing 100 different dice rolls. If I do this 1.71 squared times 100, I get 292.41. And that gives me my variance. Now, to go from my variance to my standard deviation, what I did was square root of 292.41. And you get, let's double check, I'm just going through here, 17.1. That's what I got. So again, what I did was I found the variance, and then I used the variance to find the standard deviation. So now I have a standard deviation for this distribution. So if I'm doing it out of 100 times, 100 dice rolls, mu is going to equal 350. Standard deviation now is going to be 17.1. There are a few ways you could get here, but here's the way I did it. And this ultimately got me to the answer we were looking for. I figured out I want to find the z-score of what I'm dealing with. Now we're dealing with the distribution of means. Now they don't mention anything here about it being a normal distribution. So you can do it. There are a couple of ways you can go here. I'm going to assume that this is a normal distribution because it's a distribution of statistics. I'm going to go with the normal distribution right now. So I'm going to go with, let's see, I got a nice little normal distribution. Average is 350. Standard deviation of about 17.1, so I'm going to keep it very basic. As you notice, I'm not even rounding for this. I'm just doing this so I can get a basic idea of where I'm going with it. Okay, and then I'm trying to find the probability of getting 75 or higher. Now, I'm just going to stick with normal distribution here. So what I'm going to do is norm CDF. You can go a couple of ways here. You can either figure out using your values here, or what I did was I used the z-score. So I figured I want to find 375 minus 350 over 17.1. That's going to tell me how many standard deviations away from the mean I am. When I did that, I got about 1.46. So I'm going to do this based on z-scores. If you do it based on values, you might get a slightly different answer. I did this based on z-scores. So I'm trying to find the probability of getting a z-score of 1.46, which looks about right, because if you look at your distribution here, it's about 1.5. I'm trying to get that or higher. 1.46, all the way up to like positive infinity, all of our 9s. My mean would be 0, standard deviation of 1, because again, I'm dealing with z-scores. And when I plug that in, I end up getting 0.0721, which would give me an answer of C here. Ultimately, I would have liked to have seen a little more information in the context of this problem, but based on the information I was given, this is the approach I took to solve it. So hopefully this helps you guys. Now, you might notice if you do norm CDF, and you just use the values you have, like 375, positive infinity, then you go with your mean of 350, and then your 17.1. Chances are you're going to get a very similar answer. Again, I went with z-scores, so we'll try it out, see what happens. Again, I'm just plugging this into my calculator. Hopefully you're doing the same using norm CDF. Of course, you should be labeling your values too. I'm not doing that for the sake of what we're doing. And yeah, if I did this, I got something very similar. I got 0.0718, which is really close to the answer we got here. Now, if you wanted to go the length of going with the t-distribution, since you're dealing with the distribution of means, you're going to find you still get a very similar answer here. Ideally, I would have loved to have been told that you're looking at distributions that are normal, but again, based on the information we went with, I went with a normal distribution, and this is where I got. So hopefully this helps you. Again, this is from the cumulative practice test and the practice of statistics at the end of chapter 10. So hopefully this helps you guys.